All right, good afternoon, class. I'm probably in a hospital right now as I talk to you guys about data sampling, and it is something that is often taught as the first chapter in the class because it kind of sets up how you would go about a study, which we've already kind of learned about how we actually do a study and how we analyze data from the studies. But chapter 4 talks about how you actually get the data that you can run these studies based on. So that's why they kind of do it in the first portion of the class. I think I might do that in the future, but I didn't. So, all right. Anyways, let me go ahead and share my presentation with you guys. Give me 1 second. All right. So, chapter 4.1, sampling and surveys. We talked about this a little bit on Friday about kind of what you could be expecting from this chapter. But here's what we'll be going over. So be able to identify the population and sample in a statistical study, identify voluntary response sampling and convenience sampling, describe how to select a simple random sample, which you guys will get into today, describe how to select a sample using stratified random sampling, cluster sampling, distinguish between stratified random sampling from cluster sampling. There's a lot of different ways to sample, essentially. To sample a population or a sample is to pretty much randomly draw people out of a crowd and say that these people accurately represent the population. And that's the important part, is to accurately represent. There's a lot of ways that you can sample people or subjects. It doesn't necessarily have to be people, any kind of study that you're doing where it doesn't actually represent the whole group very well. So we're going to go over how you can do that so that when you are looking at your sample, which is a group from a larger group, you can say this group that I have, the smaller portion, accurately represents the entire group. So that's kind of what we'll be working on throughout this chapter. And you guys should be able to know all the different methods to do that by the end of this. If you've already taken statistics with Mr. Brandt, this is definitely something he covers a lot. So you should be pretty familiar with it. So if that's the case, you should expect to do pretty well. You'll all do well because you're all great students and I'm a great teacher. So that's just the way it works. All right. So the population, guys, is something we've all talked about, is just the whole group, every single individual in that group. So for instance, if I was going to run a study about the United States of America and the people that lived in the country, the population would be, in fact, the population of the whole country. Every single person that lives in the country or is a citizen in the country would be that population. And a census would have me have to ask a question or to study every single individual. So I'd be collecting data from every single individual. So we have censuses, sensei, I don't know, whatever the plural for censuses is. Okay. But we have them in the United States where we ask questions about every single person in the country. It's usually done by the government, and they also use this time to collect the population size. So they often do it by state first, how many people are in each state or city, and then they break it up and they find out how many people are currently living in the United States. And they often, when you are voting, well, no, not voting because they want to collect every person, but they try to get info from every single type of person. So for instance, a census may not be something where you ask questions, but it just talks about like the ethnic background of every person, right? So when we're looking at data talking about the percentages of people in the United States that are white or African American or Latino or whatever it may be, those are from data that's been collected by a census. So, you know, all right, just by looking at someone's birth certificate or by looking at their social security or whatever it may be, you can find out what percentage of your people or how many exactly people in your country or in your population follow a certain data set. So not every survey actually asks someone a question, but a lot of these surveys and data studies are often just knowing facts about something. So when you study a whole population, it can be hard to make sure that you actually are getting every individual. So that's a population. And then a sample would be, all right, I have my population of all my people in the United States. I'm going to send out a survey, or I'm going to randomly select 25% of them, right? And the word randomly is really key. But then you get that 25% of the whole group, that'd be a sample. Okay. So sample is just a subset or a smaller group. No, not every sample is random, but we want to make sure that we do get random samples. Moving on. Okay, so you got population sample, you collect data from samples to represent the population, and then you make an inference about the population as long as that's a good sample. So we often do draw conclusions about a population by just looking at a sample, and I think this is something that we'll get into more as the year goes on. But the larger your sample, the more confident you can be in that sample that it actually represents the population. If we run a study based on a sample, it's called a sample survey, where you collect data on a sample and then you use that to represent a population. When you are making a sample survey, there's three main steps you need to follow. Decide what population you want to describe, decide what you want to measure, and then how are you going to choose to sample it. So those three things, and you'll actually have questions later on where you're asked to make a survey and you have to choose those three things. What population, what do you want to measure, and then how do you want to sample your population, okay? So those three things for a sample survey. Feel free to pause me if you're trying to take notes. Okay, now there's a lot of ways you can sample. There are things we want to avoid. We do not want to convenience sample. A convenience sample is just pretty much, say we were in class and I wanted to know something about our school, right? So who prefers chocolate milk over regular milk in our school? And I want to make an inference. So the first thing I'd say, what is my population I want to study? I'd say Reedsburg Area High School. What is the thing I want to measure? I would say preference of chocolate milk over white milk. And then the mode of sampling, I would just say, I'm going to ask the people in my AP stats class, okay? That is called a convenient sample. I'm just asking the people that are around me. First, you surround yourself with people that are like you. Now, not necessarily in this case, but if you just were to ask your friends, you're probably going to get a group of people who all kind of have similar opinions on things. Chocolate milk, white milk, maybe not such the case, but if I were to ask political opinions, or is math a good thing, right? There's certain groups of people that when they're clustered in a certain setting, they're all going to have similar answers. That's called convenient sampling. You just ask a question or you sample the people that are people or subjects, I should say, or individuals that are just the easiest to reach. So if I wanted to make a study about, I don't know, kangaroos, right? And I just went to the zoo and studied just the kangaroos that were at the zoo, and then I use that study to represent all the kangaroos in the planet, is that going to be a good representation? No, they're going to be treated differently. They have different diets and everything's going to be different, right? It doesn't actually represent all of the different kangaroos on the planet. Does that make sense? Okay. I don't know why I'm asking you questions when I can't see you actually answer. But I don't make video lessons often, so I'm not very good at it. That's okay. Some would say I'm not very good at teaching, period. So that's fine. That's called convenient sample. When you're just trying to get your easiest to reach results so you can do this as quickly as possible, it makes sense, right? It's convenient. It does not always result in good sampling. All right. Already said that. So the design of a statistical study shows bias if it is very likely to underestimate or very likely to overestimate the value you want to know. Okay. So say, for instance, I want to know who likes chocolate milk or white milk, right? And I asked this question of people at a Hershey's factory, right? I'm going to obviously get far more people picking chocolate milk versus white milk than I would just out in the real world. It's going to create obvious bias. These people clearly like chocolate, right? And it may not act that way. They might be so sick of chocolate, who knows? But it's not going to be a proper representation of who likes chocolate milk, right? And in your class, I don't know, you guys seem like white milk kind of people. So I don't know. But there could be bias in anything, right? So you have to look for those kinds of things when you're selecting your sample. You don't pick a group of people that are subjects or individuals that are going to have bias in their answers, right? You want to make sure that it is going to be as even as it would be for the rest of the population. And it's more than just bad luck. It's actually like having people have predetermined opinions because of a certain reason or like an outside variable. So like, for instance, asking, do you want to go to college to AP stats students compared to asking that to the entire population of the school is going to have bias. You guys are taking an AP class. You clearly have some, or maybe not all of you, but I believe most of you have intentions of going to college. So there's going to be obvious bias in your answer. I'm probably beating this horse. Move on to the next thing. So convenience sampling almost always results in bias, but so will some other sampling methods. Voluntary response sampling. I talked about this a little bit on Friday. If I were to send an email out to everybody in the school, asking them if they like chocolate or white milk, we talked about this, I think Kate said, the people who are really, really, really pro chocolate milk or pro white chocolate milk or anti chocolate or anti white milk are going to answer this because it's something they're passionate about. You know, they really, really care about chocolate and white milk. It's like their life goal. Those people are clearly going to respond. But Joe Schmo over in Shivi's study hall that doesn't care about any of this stuff, he's lactose intolerant, he doesn't even drink milk, he's not going to respond, right? So we're taking someone out of that population or out of that sample, but he is a part of the population. His opinion matters, right? Just because he doesn't care enough to answer does not mean that he does not have an opinion. So we have to ensure that when we are sampling something, that we're not removing people neglecting to join our sample. So voluntary response sampling can be a pretty tricky thing to get around sometimes, but you'll learn some methods to get around that. This is actually really common, and a lot of statisticians, or I should say, people that are trying to push their agenda do this, where they allow people to answer, right? Or they'll word a question a certain way. I don't know if you guys have started getting calls like this yet, but I get calls from like political campaigns all the time where the first thing they say is, "Hi, do you think that the streets of America should be safe?" Well, like, yeah, of course they should be safe. All right. Of course I just hang up as soon as I hear any of this stuff. But anyways, the next thing they're going to say is something like, well, who would you prefer to vote for? Would you prefer to vote for a man who supports the police or someone who wants to defund them? Right. So the first thing they do is they already get the right kind of person they want in their survey. So that's convenience sampling, right? And they're getting bias in as well. But then I also can just choose to hang up because, oh, I don't want to hear about political agendas of the right, or I don't want to hear about political agendas of the left. I'm just going to hang up. Okay. So immediately they just say, we asked the same question to every person, and these are the responses we got. And it was overwhelmingly positive in our candidate's favor. Right. But now what they've done is all the people who just get angry and hang up or just don't care and hang up with that might have other responses are no longer represented in that sample. So that's not an accurate representation of the population. That's called voluntary response sampling, where people can choose to, people or subjects or individuals can choose to avoid the study. You have to force people to do this. All right. It's very direct. What was the other thing I want to say about this? Oh, and same thing with that other question. That's called a leading question, where I'm leading someone toward an answer, a desired outcome. We'll get into that later. Okay, now random sampling. This is what we want, where you have a population and there's some way that you put them in a list, right? Where their opinions, their virtues, their attitudes, their demographics do not matter. It's just all put into a list and you randomly select people on this list, right? There's no vetting or anything before these individuals or subjects are put into your sample. So it's called a random sample process. It uses a chance, like maybe rolling a die or flipping a coin. Do I call this person? Do I not? Do I put them in my study? Do I not? That forces people into this study, okay? And rather than just picking out the 10 houses next to yours, okay? It's called random sampling. A simple random sample is where you take literally all those people, whatever your sample size is. Say you have a sample size of 50. You want 50 people to represent your population, okay? And you assign a number, 1, 2, 3, 4, 5, or some way of assigning people through this list, and then just simply randomly picking one. Our calculators actually do this for us. It's really nice. And we also have table D in the back of the book that does it as well. Okay, it's called a simple random sample. You'll see SRS or simple random sample throughout this whole chapter and in the chapters to follow. Okay, so simple random samples. I want to show you how to do it now. All right, so let me go ahead and stop this and then share this. Share. Okay. So if I want to have a sample size of, we'll say 20, All right. I want a sample size of 20. And there's, in my population, we'll use our school. I want a sample size of 20 and our school of 900-ish people. All right. So I'm going to click math and go over to probability. It might be PRB in your calculator. All right. Math probability. Come down to random integer right there. Hit enter. Now, some of your calculators may have this nice list. Some may not. If you do not have this list here, you just hit your values and then just separate them by a comma. So you have to memorize it. But it's all right, not a big deal. So your lower limit, we have 900 people in our class or in our school, 900-ish, like 860 something. We'll just say 900. You need to have each person an assigned number. So like Alonzo, for instance, would be an A. And by his last name, he might be like 1, for instance. Or Owen Abrahams would be like number 1. And then you'd have someone with the last name of like Z or something really low, they'd be like 900. Make sense? Okay, so you have some way of labeling them that has nothing to do with who they are. So even if it does have something to do with them, it doesn't matter because they're going to get randomly selected. So my lower would be 1. Enter. My upper would be 900. Whoops. 900. And then I said I wanted a sample size of 20. N represents sample size. So we're going to say 20. Then you select paste. If you're doing this in your calculator where you have parentheses, so it'd be random int parentheses, you just hit 1, 900, 200, close your parentheses, hit enter. And you hit paste. And Maru, I don't know what the heck you're going to do. Good luck. I will try to figure that out for you, but no promises. I'm gone for 2 weeks. So YouTube. All right, you hit paste. Hit enter, and it gives you 20 numbers, okay? So 20 numbers between 1 and 100 have been given to me. So now I have, let's see if I can pull this up here. Well, on my emulator doesn't work very well. But you've got 20 numbers, all right? Now you've randomly selected your sample. It's a simple random sample that has been selected, and those are the people that you use in your sample, or the subjects, individuals. I keep saying people, but it's not necessarily going to be people, all right? That is how you do it in your calculator. It's by far the easiest way, in my opinion. However, your book also has some methods you can use as well. So if you go to the back of your book, let me stop sharing this here. And I'll just share my screen. Let's do that. All right. Escape. All right, you got table D, okay? So you can choose any line you want. It doesn't matter. Wherever you start, doesn't matter at all. And what you would have done here is say you have 20 people, right? You want to pick out 20 people. What we would do is we'd say out of 900 people, that means that we're going from 001, which is one person number 1, up to 900. So we have to choose 3 digits as our interval. And every 3 digits, you're going on to the next you're selecting a person, okay? So for instance, what we would do, this is a totally randomly generated list. Say we start at list 120, okay? I'll zoom in here a little bit for you guys. 120, I go to 354, that's my first person. And then you never go from one line to the next, if I remember correctly. Let me double check this. Okay, yes, you do. Sorry. So only numbers 0 to 900 work for us. So if we got like 958, like this one here, we'd skip this one. We would not include that in our study. So person number 354 would be chosen. We'd write him down. Person or her 765 would be chosen. Then we do 597, 239. Whoops. 421 would be in our sample. And we would do this until we got 20 options. So 658 would be there. 50 or 500 on the nose would be there. Then we'd go 426 and so on until we had 20. We're writing this down as we go. And then we go check our list and see who those people are, or who those subjects are, or individuals. Totally random. You would not pick these people because they'd give you the desired outcome that you wanted. These people were from your population and it randomly picked them. Okay. That's the best way, one of the best ways to do it. Or you can use your calculator. Both options work. I know that the homework problems will have you do both of these. Okay, let me pause here and collect myself.